Welcome everyone. Today we are going to do the following exercise about lotteries and utilities. So it's as follows. So Richard is deciding whether to buy state lottery ticket. Each ticket costs $1 and the probability of the following winning payoffs is given as follows. So the probability, you can see it right here. The probability is 0.5 with a return of 0, 0.25 with a return of 1, 0.2 with a return of 2, and 0.05 with a return of 7.5. Now, the first question is, what is the expected value of Richard's payoff if he buys a lottery ticket? So, if he buys a lottery ticket, we will get the return. So, as we can see, if we define the return as follows, the return are the random variable r as the return. R can be 0 with a probability of 0.5, 1 with a probability of 0.25, 2 with a probability of 0.2, and 7.5 with a probability of 0.05. Now, the expected value will be to multiply 0, the value of the variable, times the probability, plus 1, which is the value of the variable, times the probability, plus 2 times the probability, plus 7.5 times the probability, which is equal to 1.025. And that's the expected value of the return. Now let's say we were looking for the net winnings. So with the net winnings, if we define the variable n as net winnings, we could have not x but n equal to r minus 1, and the expected value of n would be the expected value of this, which is r minus 1, and we can rewrite this since the expected, we can expand this, and we get the expected value of r minus 1. And this is the solution. Well, the solution of the exercise is this one, although we computed the net winnings also, the expected value of the net winnings. Now let's go ahead with the second part of the exercise, part B. So for this particular case, we are going to assume that we have a utility. See, Richard's nickname is no risk Richard. He's an extremely risk averse individual. So would he buy the ticket? Just with the solution we got, 1.020 or this one, we may say that he would play. But there is here a detail which tells us that risk is extremely risk-averse individual. Extremely risk-averse individual means that he plays applying a utility which is of the form u of x equal to the square root of x, or something which is of the form concave. I think it's concave or concave. I think it is the word. As if you plot it, we will have this kind of shape. Okay, so this would be our utility. u of x. Okay, any function of this form will work. Okay, now, and we are going to assume also that we are risk is his starting point is having his original money is 9 euros, so $9, okay, or dollars for starting. So let's get the variable x, which is the net winnings. Okay, so in this particular case, x would be 9, the original, minus 1 because he spends 1 for the lottery ticket, plus r, which is this gets the following values: 8, 9, 10, 1, and 15.5. With the probabilities 0.5, 0.25, 0.2, and 0.05. So we need to compute the expected utility for x. Now, this will be in the particular case that he plays, but if he doesn't play, the utility will be just he won't lose money, he will just have the value with probability. It would be with, this would be equal with probability equal to 1. Now we will compute the utility for x and the utility for y. Utility for y is expected value of the square root of y, which is, since y is 9, we get 3 times 1, so we have the value. Now, what about the expected value for x? It will be of the square root, which is, since we have here the variable, we will compute the square root of 8 times 0.5 plus the square root of 9 times 0.25 plus the square root of 10 times 0.2 plus the square root of 15.5 times 0.05. Now, if we compute this value, we get 2.9935. Okay, so we conclude that the expected utility for x is less than the expected utility for y, which means that we rather not to play because we get more money or just not playing. Okay, so that would be the outcome: not playing, okay. Now let's see, the next part would be so let's assume that Rick was offered an insurance against losing any money. If he buys 10 lottery tickets, how much would he be willing to pay to insure his gamble? So if Rick buys 100 tickets, it is likely that he will have the expected value will be, the expected return. If he buys 100 tickets, the expected return would be 1,000 times 1.025, which is 125. Okay. Now he would not buy any insurance, as he expects to return more money than the money he is spending. What about next part? Oops. So the last part of the exercise is in the long run, given that the price of the lottery ticket and the probability return table, what do you think the state would do about the lottery? So as we saw, since the expected value of any player or the return is greater than the cost, it implies that even though the state administration won't, will stop the lottery. Stop the lottery, since they will lose money in the long run. Okay. So that was what I wanted to show you today. Bye.